So class, this will be the next video for section 12.2. So we'll just have one video on this section. Deals with addition and subtraction of vectors. So suppose we have two vectors, u and v, and they're given in column form here where u is 5, 0, v is 3, 4. If we wanted to add these two vectors, u plus v, interpreted geometrically as first move along vector u followed by a move along vector b. So we could actually move this vector down. And if we're thinking how we're going to add these, so this is my vector u, that's really going to be the same thing as u plus v along this new vector. All right, so this new vector is called the resultant vector. U plus v is the third side of the triangle formed when u and v are placed next to each other, head to tail. All right, so with addition, though, remember addition is commutative. So vector addition is commutative, meaning order does not matter. U plus v is the same thing as v plus u. So we can go in either direction, but we get a resultant vector when we add those two vectors together. Now we can also talk about subtraction of vectors. So again, using these two vectors again, 5, 0 and 3, 4, u minus v is interpreted geometrically as a move along vector u followed by a move along vector v. We write this more often as addition of that negative piece. So u plus a negative v would be the same as u minus v. If we were to write this out, so u plus a negative v, u is 5, 0, plus the negative of v, or you could just simply say subtraction of my vector v, which is 3, 4. So 2, negative 4 would be my resultant vector after subtracting these two vectors. Okay? Subtraction is not commutative. So make sure you are doing this in the proper order. So subtraction is not commutative. Make sure if it says u minus v that you're doing u minus v or u plus the negative of v. Okay? And again, they're subtracted simply by adding the negative vector. So this goes back to what we were doing in the last video when we were doing position vectors, where if it was OA, we could think of that as the negative of it if we were going from A to O. The zero vector. So let's consider the triangle PQR here. If I started at P and I went P to Q, so I went along this route, and then I went Q to R, I went along this route, and then I went R to P, I end up right back where I started at. So this must be equal to 0 as the overall journey results in a return to the starting point. So if we have this PQ plus QR plus RP equals 0, this is the 0 vector. And it will be in this bold 0 font. And in one dimension, this is column form 0, 0, in 2 dimensions, it's 0, 0, 3 dimensions, 0, 0, 0. All right, so now we can get into geometric proofs. So suppose we have a triangle OXY, and we also have values A, B, and C that are the midpoints of OX, OY, and XY. Now we are going to denote the vector OX with the boldface X and OY with the boldface Y. So let's get an idea of what we're working with here. So we just have some arbitrary triangle OXY. So we can just draw some triangle here. I'm going to call this O, I'm going to call this X, and I'm going to call this Y. I'm going to be more specific. This is going to be a capital Y. And this is a capital X. So OXY is our triangle. Now we have midpoints on there. So my midpoint of OX is A. My midpoint of OY is going to be, on this one, I could say it's C, I'm sorry, not C, of OY, this is going to be B, and then of XY, that is going to be C for my midpoints. So I have this triangle here, I have OX, XY, OY, I have the midpoints on there. Now it's saying also our vector OX we're going to use as a boldface X. So I'm just going to change the color up a little bit. So this I'm really going to call my vector X, this my vector Y. So this is what it looks like if I were to draw this situation. Now let's do some work with it. So let's find expressions for OA in terms of X and Y. So if I were to write this out in terms of X and Y, so OA, since I know it's the midpoint, it's halfway along OX, but I know OX is really that boldface X. So 1/2 X is going to be my OA in terms of the boldface X. If I wanted to find OB in terms of XY, well, OB is going to be represented by half of OY. And I know OY is really my boldface for my vector. And so this is going to be 1/2 of Y. If I wanted to find XY in terms now of X and Y, so that third side of my triangle, I could rewrite this and say, well, XY is going to be XO. So again, we're trying to find another route to get from X to Y. So I'm starting here. I'm going to go back this direction. So XO plus OY. But I know XO is actually the opposite of my OX, so I can write this as a negative X. OY is just Y. So this would be negative X plus Y, or I could write this as Y minus X. So that would be XY in terms of the boldface X and the boldface Y. If I wanted to do OC now in terms of XY, so OC would represent this piece right here. Well, OC is going to be, if I want to get from O to C, I could say, well, I can go from O to X, and then I could go then from X to C, and that would get me to where I wanted to be at. Now written in terms of my boldface X and my boldface Y, OX is really the boldface X plus, I know I'm at a midpoint, so plus 1/2 of XY. 1/2 of XY, I can rewrite this because in the last slide we found out that XY was really Y minus X. So now I can say I'm going to have X plus 1/2 of Y minus X. Work this out. So this is X plus 1/2 of Y minus 1/2 of X. Combine like terms. X minus half of an X is going to give me 1/2 X plus 1/2 Y. Common factor is 1/2. So I can write this as 1/2 of X plus Y. So again, that is OC written in terms of X and Y. If I want to find now CO in terms of X and Y, well, I found OC. I found OC just a minute ago. If I went OC, I ended up with OC was 1/2 of X plus Y. Well, now I'm just going in the opposite direction. So if I'm going in the opposite direction, if I want to go from C to O, so CO is going to be just a negative 1/2 of x plus y. All right, let's look at another part. Find an expression for AB in terms of x and y. So again, I want to try to figure out how I can get from A to B. And direction is important. So A to B going this way. Well, I know AB is going to be represented. I could go from A to O and then from O to B. And so this is going to be AO plus OB. We already found this information out. So AO, we could say that's really just a negative 1/2 of x because O to A is 1/2 of x. So A to O is the opposite, negative 1/2 of x plus 1/2 of y. So this ends up being 1/2 of y minus x. If we look back at part A a little bit, we know that x, y, capital X, y was y minus x, and AB is actually 1/2 of y minus x. So we can see they are scalar multiples. And if we remember from the last section, if they are scalar multiples, this means that they are parallel. Oh, right there. What's the relationship between x, y, and AB? They are parallel. All right, part C, same setup. But now we have some point P such that if I went from the origin to P, it would be the same as OX plus 2/3 of XB. So what this is saying, I'm going from O to X, and then from X to B, I'm only going 2/3 of this distance. So P is going to be some point here in the middle of my triangle. So I went from O to X, and then 2/3 of the way from X to B. I want to actually find, well, what is OP? So what is this distance here from O to P? Well, we can work through this one as well. I know that OP is going to be represented by this OX plus 2/3 of XB. And I know that OX is really my boldface X plus 2/3 XB. If I want to go from X to B, I could also go from X to the O back to the origin plus O to B. So this is my boldface X plus 2/3. XO is really just the opposite, so that's a negative X plus O to B, I know, is 1/2 of Y. So now I have X minus 2/3 X plus 1/3 Y. If I have 1 subtract 2/3, that leaves me with only 1/3 X left plus 1/3 Y. So then I can say 1/3 X plus Y is going to be OP. Last part. What can you conclude about the position of P? So remember, we found that P is somewhere in here, 2/3 of the way across, right about there. What can we conclude about the position? Well, we know OC is 1/2 of X plus Y. OP is 1/3 of X plus Y. if I wrote this as a ratio, if I did OP compared to OC, I would end up with 2/3. So what I can conclude is P is 2/3 of the way along OC. So if I were to draw an OC, I would see that my P is also 2/3 of the way along OC, and it's 2/3 of the way along OXB. All right, so there's a couple problems. So numbers 2, 5, and 6. Second part, 1 and 3. On number 3, part D should be the vector CD. So make sure you make that adjustment on number 3, part D for the second part. So that's the last lesson for this first week. Next week, we'll do a few more sections on vectors, and we'll keep going.